A binary operation star is defined as shown in the table. Find the inverse of C under the operation star. We have to look for the inverse of C. So we have C operation C inverse is equal to E. That's the inverse property. So for us to be able to get C inverse, we need to get identity. So we say first determine identity element. First determine the identity element E. So the identity element E means C operation something that will give us C. So from the table, so from the table, C operation what will give us C. So let's look, that's whatever that is, whatever will be here, that will give us C when C combines to it. That's the identity element. So let's look at C operation what will give us C. C operation, okay, that's C operation D will give us C. So C operation D will give us C. Now, so this tells us that therefore D is the identity. Therefore D is the identity element. Now that we've gotten the identity element, remember that C operation C inverse equal to E, where E is the identity element. Identity element is equal to what? Is equal to D. So we say D is the identity element is equal to D. So this will give us C operation C inverse will give us D. So what we're going to look for is that what from our table to get C inverse, C operation what will give us D. C operation what? So let's look at taking to get this and say taking okay from first column, let's see what C gives us. C operation E. C operation E. What is it giving us? C operation A is B. No, E is not the inverse. E is not the inverse. And C operation B. C operation B is what? Is D. C operation D. Remember our identity element is D. So C operation B, if it's giving us D, that means B is the inverse. B is the inverse, because the rule says that C operation C inverse will give us B, and D is the identity element. So therefore B is the inverse. B is the inverse of C under the operation star. Under the operation star. Under the operation star. The multiplication table above has modulo 10 on the set S 2, 4, 6, 8. Find the inverse of 2. Inverse of 2 would be 2 multiplied by inverse of 2 will give us identity, give us E, which is the identity element. So first thing to do is to determine our E. First, determine E, the identity element. So to determine the identity element, it means 2 Of course, you know that 2, if you know the 2 multiplied by a number that will give us 2 multiplied by something, 2 multiplied by, okay, let's say from the table, 2 operation what will give us 2, 2 multiplied by what will give us 2, 2 times 2, 2 times 2 will give us 4, so let's say 2, taking 2 times 2 will give us what, 4, 4 is not, 2 is not an identity, 2 is not an identity because it did not give us 2 back, so 2 times 4 will not 10 is 8, so 4 is not an identity, 4 is not an identity, 2 times 6, and 6 more 10 is 2. Now, 2 multiplied by 6 will give us 2. And the rule for identity is that for identity or identity property says that A operation E should give us E. So here 2 multiplied by 6 is giving us 2. So we say 2 plus 6. 6 is an identity. 6 is an identity. An identity or an identity element. So therefore we say the identity element is 6. So next, determine the inverse of 2. To determine the inverse of 2, and we need to see 2 multiplied by the inverse of 2 is equal to 6, which is the identity element. So let's see, let's carry this out. So 2 multiplied by what will give us 6. 2 multiplied by 2 will give us 2 multiplied by 2 is equal to 4. It will give us 6. So 2 is not the inverse of 2 is not an inverse. 2 is not an inverse. 2 times 4 is equal to 8. 4 is not an inverse. 2 times 6 is giving us 2. 2, 6 is not an inverse. And then 2 times 8 is 6. So 8 is an inverse. So therefore the inverse of 2 is 8. So 2 operation 8 will give us 6, which is the identity elements of this mod, this operation. So in the table above, find the inverse of 4. So solution. So that means 4 operation inverse of 4 to give us identity where E is the identity element. So first, determine the identity element E. To do that, I will give us that will give us from the table 4. I was using the colon, the row. I'm using this colon against this row. So 4 operation 4 star 1. What's the result? 4 star 1 will give us 4. 4 star 1 is 4. So that is it. 4 from the table 4 star 1 is 4. So 1 is an identity. One is an identity. If you go on, you see that for operation 2, what's it giving us? It's 3. 2 is not an identity. And let's say 114 operation 3. For operation 3, what's it giving us? 2. 2 is also 2. 2 is not an identity also. Okay, so it's therefore the identity element before the identity element is 1. Now for inverse, it got to be 4 operation, inverse of 4 to give you this identity 1. So from the table, let's go again. So 4 operation 1, we intend to get 1. 4 operation what will give us 1? The identity element 4 operation 1 is 4. Because of 4. So we say 1 is not an inverse, or the inverse. 1 is not the inverse of 4. So 4 operation 2. 4 operation 2 is 3. 4 operation 2 is 3. So 2 is not the inverse of 4. 4 operation 3. Operation 3 is 2. 3 is not the inverse for operation 1. For operation 4. Operation 4 is 1. And we said for inverse, 4 operation inverse of 4 should give us 1. So 4 operation 4 is 1. So therefore 4 is the inverse of 4. So therefore the inverse of 4 is 4. In the table above, O plus is the operation defined on S, where S is a set of K, L, and N. Find 1 the identity elements, 2 the inverse of M. So 1 where the identity element so get identity element where let's use K. You can use any of the letters here, but let's use K. Let's try K. So from the table, or so the identity element usually let's say E star B or E star E equals E. So this is our guide. So we intend to any data we use here, K operation what here will give us K back. So if you are using L operation what here will give us L. So let's use from the table K operation K is equal to L. It will give us K back. So K is not identity. It's not an identity element. It's not an identity element. So K operation L is equal to N. So L is not an identity element. Next is K operation n. K operation n is k. So since we got k back, this tells us that n is the identity element. As far as this table is concerned, n is the identity element. So therefore, the identity element is n. So the inverse of n, or inverse n operation n give us e, where e is the identity element, and which in this case is also n. So from the table, n operation what will give us n. So let's say n operation from the table, this operation is o plus n operation k is equal to k. So k is not the inverse of n. K is not the inverse of n. N plus L. What is it giving us? L. And L is not the inverse. The inverse of n. N plus operation n. What is it giving us? N. So n is the identity. So n operation n, if it's giving us identity, that means n is the inverse. The inverse of n. So what do we say? Therefore, the inverse of n is n. This is quite unique because n is the identity element, and it's also the inverse of n. So that's the answer.